This type of problem is called a work problem because what we have is two people. One, Maria, takes 13 hours to do a job by herself, and Bill, another person, and it takes Bill 14 hours to do the same job by himself. So what happens if you put these two together, so working together, how long would it take them both to complete the job? So one person takes 13 hours, another person takes 14 hours, but if you have them work together, how long would it take to complete the job? Well, we don't know how long it's going to take to complete the job, so why don't we do this? Why don't we let x equal the number of hours it takes working together to complete the job. That's, after all, what we're looking for. So let x be the number of hours it takes to complete the job when they work together. We could approach these work problems this way. Suppose, like for Maria, I'm going to draw a little picture here. So suppose for Maria, it takes her 13 hours to complete the entire job. In 1 hour, she complete 1/13 of the time it takes to. Now it takes Bill 14 hours to complete the same job, so in 1 hour, it takes Bill 14 hours, so in 1 hour, Bill can complete 1/14 of the job. And now working together, they can complete the job in X hours. So in 1 hour, this sounds a little strange, but it's fine. They can complete 1/x of the job. Let's just run through it again. So Maria takes 13 hours to do the entire job. So in 1 hour, she can complete 1/13 of the job. Bill takes 14 hours for the entire job. So in 1 hour, he can complete 1/14 of the job. And together, as a single person, they can complete the whole job in X hours. So in 1 hour, they can complete 1/x of the job. And this actually gives us our equation. So what we've got is 1/13 of the job plus, because we're getting help, 1/14 of the job is equal to 1/x of the job. And now this is a rational equation, so we know what to do. We'll get the LCD, and you know what I'm going to do here? I'm going to write this 13 times 14x. I could go ahead and multiply the 13 and the 14, but you'll see why I'm not going to do this in just a minute. And of course, we need to get our excluded values. So we'll say x is not equal to 0, right? X can't be 0 from here. But 0 doesn't make any sense anyway because x is the number of hours it takes working together. It can't take 0 hours to complete the job. So let's multiply each one of these terms by the LCD. So we'll write the LCD alongside each original term. And we're going to get, if we do this, we'll get 1/13 times 13 times 14x plus 1/14 times 13 times 14x equals 1/x times 13 times 14x. And now we can see we get some cancellations here. So this 13 will go with that 13. And now maybe you can see why I wrote the LCD as 13 times 14. Because if I didn't do that, if I actually multiplied it out, I'd have some big number, I'd have to divide it by 13. But there's the 13 right there, so I'm just not going to multiply. So the 13s will cancel. Let's do that. And then when we do that, we will get 1 times 14x, or just 14x. And then over here, the 14s will cancel. So let's do that. We'll cancel that 14 with that 14. And we will get 1 times 13 times x. So let's write that. We'll get plus 1 times 13x is 13x. And then over here, the x's cancel. And we'll get 1 times 13 times 14, so let's cancel those x's. So we'll get 1 times 13 times 14, so that will give us, I'll just write it as 13 times 14. And then right from here, we'll get 27x is equal to 13 times 14. And it turns out if we convert this improper fraction to a mixed number, this comes out to 6. And 6 times 27 is 162. 182 is 27 hours. So we're going to conclude that working together, it takes Marie and Bill 6 and 27 hours to complete this job.